Hello, this is a video explaining the way prime numbers can be used to safely transfer data, so like PIN numbers and stuff, online. Before we go into that though, we need to just quickly go over a few definitions. It will make sense, don't worry. So our first definition is the Unifi function. The Unifi function essentially says that for a number n, for all the numbers less than n, we want to find out the number of them for which the greatest common divisor of those two numbers is 1. So if we look at some examples, for the Unifi function being 12, we have 1, 5, 7 and 11, so this gives us a Unifi function of 4. If you want to think about this, think of like the number 8. 12 and 8 are both divisible by 4, therefore they have a common divisor greater than 1, therefore it is not included in these numbers and so does not become part of this 4. Another example is 8. So we have 1, 3, 5 and 7, this also gives 4. And lastly we have 7, and if you'll see this gives all the numbers less than 7, 6. And this happens for every prime, and it's very important, we'll look at this later, that every prime produces all the numbers less to it, so its Unifi function is 1 less than itself. So this next definition is about modular arithmetic, and the easiest way I can think to explain this is if you think of a 24-hour clock versus a 12-hour clock. So 13 o'clock is the same as 1 o'clock. Essentially, modular arithmetic is just creating an equality between numbers from a certain point. So if we look at this in terms of modular arithmetic, 13 equals 1, we can write this as 13 mod 12 is the same as 1. Or 7 mod 12 can also be written as 19. They're the same, they're equal. So if we look at this on the whole for mod 3, we can see that there's just this infinite amount of numbers for each different mod value. For 0 we can have 3, minus 3, 6, 9, 12. For 1 mod 3 we can have like 4, minus 2, 7. And for 2 we get the same. And this is essentially modular arithmetic. And it's quite a handy thing, and yeah, we're going to use it. So before we can send the site secure information, the site has to set up a sort of key system for us to use. And it's pretty much like this, how they set it up. So they choose two large prime numbers. I've gone for 3 and 11. Obviously they're not that large, but this is just an example. And then we do the 5 functions of them, and because they're both prime, we know that that's just going to be 1 less for each of them, and we multiply them together. So we end up getting 2 times 10 equals 20. Next we choose a number which has a greatest common divisor with our 20 of 1. So 7, nothing divides into 7 and 20 other than 1. So it's the greatest common divisor of them. And then we try to find a number which, when multiplied by 7, gives us 1 mod 20. So we can see that 3 times 7 equals 21. 21 mod 20 is the same as 1 mod 20. So done there. And then essentially the site publishes our 7, which was the number which had a common divisor of 1 of our 20, and the 33, which is our initial primes times together. And they keep this 3, which was used to get the 1 mod 20 secret, because they need to use it later. So now that the site has put out those keys, we might want to send them something. So this is how we do that. So given the public key, which we had from before, with the 7 and the 33, so we want to send them 2. What we do is we put 2 to the power of this number, and then do it by mod of this number. So we have 2 to the power of 7, 33. And by some fancy maths, this turns out to be 29 mod 3, through like computers or whatever. So we send them 29. So now we come to the decoding, and this is where they use the private key 3. So by putting 29 to the power of 3 mod 33, we then get back out our 2 to begin with, and so we've sent them the message. Brilliant. So yeah, that's what I really wanted to say on that. I thought it was quite neat. I might do an explanation video if people want it, but there you go. Prime numbers, who knew?